All right, we got one last video here, and in this video we're talking about rational expressions and radical expressions. How do I simplify something that has a fraction, okay? Sometimes it's really easy, like over here on number 6, those are all x's, right? There's no y's or z's or anything, so honestly, all you're going to do, write that as x to the 6th fourths, and write that as x to the 5/7, and then just subtract the exponents, right? Use easy rules when possible. But here we have different values, okay? And so we're going to run across a couple of different things here. The first thing is this. First of all, I can break this up into separate fourth roots, okay? So I'm going to call this the fourth root of x to the 4th, and the bottom is the fourth root of x to the 7th, right? And the nice thing about this is that I have x to the 4th, and I have a fourth root, and those cancel out. So that just becomes a plain old x on the top. The bad news is that I have y to the 7th on bottom, and I have y, and then I have the cube root, or the fourth root of that, obviously, right? So I think the easiest thing to go about it is this, okay? The easiest way to do this problem is to rewrite this as y to the 7/4, and you're going to see why in a second. The problem with this answer, see, we're getting pretty darn close. We're getting pretty darn close here. If I just called that x over this radical sign, I'd almost have the answer. But just like we had to rationalize the denominator in previous units, the problem is we don't like square root signs or radical signs in the bottom of a fraction. It's just a no-no. You don't do it, okay? So we need to find a way to get rid of this radical sign. And the only way you can get radical signs to go away is if we have like a perfect multiple of it, like what we did here where we had x to the 5th, and we could say, well, 4 of those come out, right? If we can make this a non-fraction, if there weren't any oddball y's left in the inside, then we could take care of this, okay? So I think the easiest thing to do would be this. I want to try something here, ready? 8/4 would be white squared, right? In order to get from 7/4 to 8/4, I would need one extra fourth, right? So I'm going to multiply both the top and the bottom by y to the 1/4 power. Okay, I chose that because 7/4 and 1/4 add up to 8/4, and 8/4 is 2. So in other words, when you multiply like this, I get x times y to the 1/4. I'm going to rewrite it real quick, okay? Instead of y to the 1/4, I'm going to write it as the fourth root of y. Okay, that's y to the 1/4. And on the bottom, I have 7/4 plus 1/4 is 8/4, and that's y squared. And you just rationalized the denominator in a quick and easy method. So, once again, the tendency is for you to go like this, y to the 7th, and to say that that's the correct answer, okay? Because it looks like when I break it up, that looks like it's what it should be, right? The x goes away, but the y doesn't, okay? But the problem is you got a radical sign on the bottom. How can I get rid of the radical sign at the bottom? I pick an easy fraction that gives me a next multiple of 4 in this particular case. All right? So number 6 really doesn't use the same method because it's all x's. That's a much easier problem. But number 4 you should be able to go and do now. And number 9 you should be able to go do now. And number 11 you should be able to go do now using the same ideas. Okay? No radical signs in the bottom. Hopefully that makes sense. So you got 8 problems to do for the homework today. And by the time you leave class, hopefully you got a pretty good idea of the patterns and how they work.